Welcome to Teaching My Wife Artificial Intelligence. And this is lecture 2, where we are revising the basics which we studied last time. So she's been a good student now. And the homework and assignment were followed. So this is the Google Doc. I will link it in the video description. So lecture 1 had this reading material, and this is what was studied. Neural network from scratch. This is a series by Syntax. It has very good visualizations, and it goes through concepts very nicely. So Shreya, what were your feelings about it?
I do agree that it's like it was very thorough, and all the concepts, each piece of the puzzle he explained from scratch with raw Python coding. Like, he didn't directly go into libraries or actual models. He was just explaining the to basically the whole focus of the series was to develop an intuition for what happens in machine learning and uh, the gradient descent and what is it intuitively. So that was good. What didn't work for me was it was too much from scratch. I
Hmm.
I was having trouble connecting what I'm learning to real world problems. So
Okay.
that was what didn't work for me. But what worked was until the part where he explained everything from gradient descent, etc. That
Hmm.
worked. But from where we started modeling on a dummy data set, it didn't work.
Okay. So the few parts, how were the visualizations? Were they
They
helpful
were
in
excellent.
understanding? Okay,
They
perfect.
were excellent. Yes.
So, anyone who is learning from non-coding background, this is a quite good lecture. You don't do entire series in one shot. Maybe you can take time across, let's say, 3 to 4 days. If you split and you watch these 3, 4 lectures, I think it will be a good thing. Let me also link a different thing here. So this is this website where all the animations are put. So यहाँ पे I will put in animations of NN concepts. Okay, so you could go to this and watch the animation. So the second thing which we did was Kaggle Learn. Kaggle Learn gets you to the code immediately. There is this course, Introduction to Deep Learning, and in that you can directly go into the coding part. Okay, just a second. So if you do this, where is this? Okay. So these are the lessons here. Shreya studied them, did the code, and in this lecture, we are going to revise the concepts, all the concepts which are in introductory, which everyone must know. So you did these 7 lessons with all the coding labs. So tutorial and
Yes.
exercises both. You completed the
Yes. Yes.
certificate.
Yeah. Entire certificate.
Okay,
Yes.
perfect. So let's quickly revise things from here. Okay. So
Yes.
single neuron. What is a single neuron? Before
Single
we go
new.
into artificial intelligence, let me first put in a context. A single neuron, just a second, okay, right speakers are selected. Okay. Single neuron in our complicated brain. Okay, our brain is made up of large number of neurons. And a neuron is a basic unit from which the entire intelligent brain is created. Similarly, in neural networks, a single neuron is that single unit from which entire artificial neural network are created. So this is just a conceptually this thing. Now, Shreya, what? So we have built flashcards. Shreya has written these flashcards. These are flashcards of all the concepts here, and we'll go through them, and I'll ask Shreya what is neuron questions from here like this. Okay, so let me get to this card. Yes, what is a neuron, Shreya? Mhm.
A neuron is a fundamental unit of a neural network. A neuron has multiple weighted inputs and a bias, and when they're summed together, they produce a numerical output, which is the prediction.
Perfect. So another way to look at it is neuron takes an input, it gives an output.
Hmm.
The input, whatever we are taking as input, uske saath there is a weightage assigned to it. So the weightage tells if it is large number with a positive value, it means that signal is more important. If it is a large number with negative value, then it is inversely important, but high importance. If it is, let's say, minus 0.1, it is less important, but with less inverse relation. So higher the weight, higher the importance. So like you said, neuron is a fundamental unit. It has input, it has output. Every neuron has weights and bias. Always weights and bias. There is a very big company around this. It is called weight and bias precisely because this it's standard. Weight is the connection weightage, and bias is a correction of a neuron. Is it in a certain direction or
So
not?
I understood this in terms of Excel sheet. Okay.
Hmm.
In Excel sheet, if you have 5 columns of data, then weighted input means to the neuron, you are saying which columns are important and which are less important.
Perfect. That is a perfect way to look at it. Awesome. Okay. Next question. What is the structure of a neuron?
It is this circle with inputs in it.
Yes,
Um,
this camera, if it zooms in, yeah.
yeah,
Maybe I'll single neuron. Let's search here.
yeah. Single neuron artificial.
Yes.
Yeah, this one. Yes.
What is structure of neuron? It is continuation of a previous question. A
Yeah.
neuron is this center wala thing.
Hmm.
It connects to all the input values. The line connecting to the input has a weight value. So
Yes.
weighted sum mein higher weightage has higher value and lower weightage has lower value. It is all summed up here, and that's the output. So that's the
Yeah.
structure of the neuron.
This
Okay.
is Excel mein when we do sum product, it
Mhm.
is the same thing that is happening over here. Wow, you don't know Excel. Which corporate reality have you lived?
Yes. So X item size sold. Small, medium, something. Okay, so this is the weighted sum exactly like a neural network is doing. So imagine a neuron as infinite such units. Okay,
Hmm.
perfect. So what else is in this concept? We have linear unit as model. There are multiple units here. And this is the coding part.
Yes.
So for code, this is very interesting to know. You can speak the code if you're doing it in Keras. What is a neuron? Neuron is a single unit. It is called as dense layer in Keras, and everything is in the right place. So Keras mein layers are in Keras dot layers. So layers dot dense and usme unit equal to 1, it is a single neuron. If I make unit equal to 10, it is a layer with 10 neurons.
10 neurons.
However, our incoming inputs, we have to specify that here. And this is finishes the first lecture.
And this is the only place where we define input, rest it takes from the
Yes.
from how the layers are connected.
So
How
Keras
you
has this separate thing where you don't have to specify input to every layer.
yes.
Only you specify the number of neurons at each, and in the subsequent ones, it automatically calculates. PyTorch, you have to explicitly say what is input at every layer. That's the
Yes.
only difference between Keras
Keras
and
and
PyTorch
PyTorch.
in visual. Okay. So ये हो गया Keras का, and then we have deep neural network. So deep neural network में what is a concept? So what is a layer? What are layers?
Layers is multiple neurons connected through activation functions. Like it's a series of neurons. So if there is neuron 1, 2, 3, 4.
Mhm.
So if you in Keras, if you put units is equal to 4, it's
Hmm.
one layer,
Hmm.
and then yes, this one layer, and then that is how do you put it? Multiple number of neurons can
At the
create
same
one layer
level, the best
at
way
the
to
same
speak
level.
at the same level, that is what the best way to articulate that would be. And in the code, let's see, let me see, run a code. So if I say import Keras, so here what I'm doing is instead of Keras TensorFlow say Keras, I'm directly importing Keras. Okay. So Keras dot layers dot dense units equal to 10, and then activation equal to ReLU.
Huh.
So
This
we
is
have
one layer.
10 neurons at the same layer, and all of them have the same activation function.
Hmm.
So the way you articulated was right. They are connected by activation function, but I don't think anyone looks at it that way. There is a activation function.
I think they are very visually registered in my brain. It's hard for me to put it into words because when you look at it visually, it's obvious what it is, but when you read verbal description, it is not very obvious what are you talking about. So I don't
Correct.
know how to bridge that gap.
Yeah, totally makes sense. This is the layer, and then this code we can again speak. The code is a network is made up of multiple layers, one after another. And here, keras.sequential is how you start a model, or you can write it in a different way. So I will write it from here. Keras.models.sequential. This is also how you can write. The reason I prefer this is model में model का होगा, layer में layer का होगा, losses में losses का होगा. It is a bit more standardized.
It is
Losses.
more intuitive.
Yes, it is more intuitive. So यहाँ पे carers.models.sequential. I will have the first layer dense. उसमें करता हूँ मैं units equal to 4, activation is equal to ReLU, and
फर्स्ट
input.
लेयर में इनपुट शेप आएगा. अच्छा, ओके.
हाँ, input size is equal to let's say 3. Input
उसका
shape है.
ब्रैकेट आएगा, स्क्वायर ब्रैकेट.
No, I think this is fine.
Why do they keep changing the rules? It's why is there no internal consistency? Everywhere I wrote this, and when I didn't write the square bracket, तो Kaggle मुझे right answer का marks नहीं दे रहा था.
Okay, dense object is not iterable. क्यों हुआ? This is square यहाँ पे.
हाँ, ये this
square. Okay, I thought तुम input shape की बात कर रही थी.
हाँ, मैं उसकी भी बात कर रही हूँ और मैं इसकी.
Yes, you're right. You have to put a square. I was wrong.
मेरे को extra marks चाहिए.
Yes, extra marks. Okay, it has run. This is the one layer, and now multiple such layers we had. Keras.layers.dense. यहाँ पे units equal to 7. Activation is equal to ReLU. If you write units, it kind of like tells you what the number of neurons are. Most people, when they're writing, they will write keras.layers.dense and 7, and let's say ReLU, something like
But
that.
one important thing, units means how many neurons are at the output of that layer.
Each neuron outputs a single value. That's why number जितने भी units
I
है
think
उतने
वो
output
मैंने
है.
पहले PyTorch में किया था ना, तो उसमें input is equal to say 3,
Yes.
and then output
Out
128,
shapes, yes.
and then
Yes.
other in shape 128. So you have to start from there. So that's why I'm saying कि when you say units in Keras, it means what you would write in out shape in PyTorch.
Yes. But यहाँ पे because we started from this thing, ये diagram जो है, तो number of neurons is number of units.
Yes,
It's
correct.
conceptually वो वैसा है.
हाँ, conceptually there is no difference.
And then you kind of like keep adding things like this. If you write the code in an explicit way, it is easier to read when you read it on your own.
It is the opposite of actually how you do writing, where we usually write to abstract, like shorten the meaning. But I noticed in code, the more explicit you are, the better your
Easier
code
it is to understand. Yes.
It's easier it is to understand what is happening.
Correct. Perfect. Yes. Even in this, I prefer to write it like keras.models. Something, because that way I don't have to remember where is models coming from, where is layers coming from. But here in this code, if you see, they have imported layer directly.
Yeah.
तो फिर उससे क्या होता है? Then I'm like, where is layers coming from? For me, it doesn't make any sense.
Yes.
Whereas if I say keras.layers, it makes perfect sense to me in my brain. So I don't know if
in my
it's
head
true.
it is registered as do you know the country of origin of this coffee type?
Yes, correct. So multiple layers, they added together, they become a neural network, and that was the question. So then third unit was stochastic gradient descent. So what is stochastic gradient descent?
So stochastic means random,
Hmm.
and gradient means traversing a curve of
Hmm.
any kind. It
Hmm.
could be a two-dimensional curve like a sine wave, or could be three-dimensional, four-dimensional, but it's a curve. And descent means always going down the curve from the higher value to the lower value.
Hmm.
So stochastic gradient descent is basically like, I would say, a mode or like a information pump.
Hmm.
It always pushes the weights, rather it always makes sure weights are always updated in the direction where the loss will be minimum. So
Hmm.
it always
Correct.
makes the weights, the network descend towards local minima.
Okay. Perfect. So very complicated explanation which you understood by doing this course. Perfect. Let's see if there is a good graph for it. Gradient descent.
Yeah. See, it's easier to explain visually. The
Yes.
second, yeah. So ऐसे ये जो ब्लैक डॉट है ना यहाँ पे, ऐसे
Hmm.
डू ऐसे नीचे
Yes.
जाता
So
है,
it's a ball as
एंड
just
हाँ
hovering and
बॉल
it
ऐसे wing
going
wing
at
and
the
then it go
lowest thing. Yes.
zoo, and it'll stabilize at the lowest point, and that
Perfect.
is where your error is minimum, and hence your prediction will be more accurate because it is
Exactly.
less
So
away from the actual prediction.
so this is what stochastic means. We are choosing a data point randomly.
Randomly.
On that data point, we do prediction and we see how wrong we are. And according to that wrongness, we correct our parameters. So it's like we take one thing, we test, and we adjust all the weights. Then we take next point, then we adjust all the weight. Then we take next point, we adjust all the weight. And how do we know where to minimize? This is where Newton and his derivatives come into picture. Wherever we are, if we take derivative at that point, it tells us किस direction में जा रहा है, ऊपर या नीचे. And once you know किस direction में जा रहा है, so if it was on the left side, we would the slope direction would have been different. यहाँ पे slope direction is different. So by knowing that, we go into the direction where error is reducing or slope is reducing, because our goal is to reach at this bottom point where gradient is zero. So that's why gradient descent, it is called, a very complicated way of saying error minimization. To minimize,
मतलब रैंडम ग्रेडियंट डिसेंट भी बोल सकते थे,
yes,
बट दे चोज
random gradient
स्टोकेस्टिक.
descent. Randomly picked data error minimization, something ऐसे कुछ तो हो जाता. But
I
yeah,
hate academic language. It's just,
yeah.
it's standardizable, but it's ununderstandable. I know that's not a
Yes.
word, but I don't care. It's ununderstandable.
Yes. So this is what Keras starts with. We have loss is it defines how we are calculating error, and with the gradient descent we are just minimizing the error. That's all it is. Okay, minimizing the error. So this is from the fundamental concept of a neural network. Then this lecture number 4, it is overfitting and underfitting. So what is overfitting, Shreya?
Overfitting is when, so we train the network on a training data set which has all kinds of patterns that you can generalize and to other data sets, thus creating real world predictions, and patterns that are just specific to the training data set, which does not exist in other data sets.
Hmm.
So overfitting is like, uh, the network learns the training data too well. So when
Hmm.
you test the error, the accuracy of on the training data, it comes very good. It shows that loss is very minimum. But when you apply the same to the validation data set, it will throw error because it has learned what is hyper specific to the original training data set.
Perfect. Perfect. So we can see this in a graphical way here. So overfitting is a neural network concept. Neuron can learn a specific small function. When we have large number of neurons working together they can learn a complicated function. So in a way, if we make a network more complex, it can learn more complex pattern. This
Hmm.
is how entire neural networks are made. So
Hmm.
if you check on the right hand side, if the points are like this and you go through every single point, this is overfitting. Where like अरे इतना नहीं है, it's just tiny bit deviation. Don't go through them all as is. So this is overfitting, and underfitting would be it's like data complex है और model बहुत ही चिंदी prediction कर रहा है.
Yeah,
It's
model is too
simplified.
simple for the
Yes.
data, so it's not able to pick up on more complex and non-linear relationships. So it is not learning well. So it throws error on both training and validation sets both.
Perfect. So this is a very important concept, overfitting and underfitting, because this is how we test where to stop, when to stop. अपना model के training में, whenever the code we write, it all comes from here. So this is a quite important lecture. So when you're studying this Kaggle learn and all the revision from it, do pay attention to this lecture. Then overfitting, underfitting, what is capacity?
Capacity is the ability of the network to learn complex relationships. So there are two aspects to capacity. One is how wide is the network and how deep is the network. Wide means एक layer में ज्यादा neurons हैं. तो
Perfect.
उसके वजह से क्या है कि it is better at predicting more if there are more linear relationships in the data set. But if there are more non-linear relationships, you need more number of layers. So each layer can have less number of neurons, but more layers stacked. And that's a deep network which has more capacity to learn non-linear relations. So capacity is like how intelligent the network is in regards to learning complex patterns and relationships in the data.
Yes. A different way to look at it, जितना deep layers,
Hmm.
उतना complicated उसकी learning. So
Hmm.
it is like हम I think ना कंपनी का जो org structure रहता है ना, we can take that example. Anyone who is on the ground, the first
Hmm.
layer of job, उसे काफी कम info पता है और वो उतना ही काम कर रहा है. That's layer number one. लेयर नंबर टू वुड बी उसका मैनेजर एंड उसको मल्टीपल लोग रिपोर्ट कर रहे हैं.
Hmm.
सो दैट पर्सन हैज एक्सेस टू मोर इंफॉर्मेशन एंड अ बिगर पिक्चर एंड मेक्स मोर कॉम्प्लिकेटेड डिसीजन. सो देन उसका मैनेजर मोर कॉम्प्लिकेटेड, जितना ज्यादा डेप्थ. And if you go to the level of CEO, then through all that abstraction, he's able to see everything. So जितना ज्यादा डेप्थ उतने ज्यादा कॉम्प्लिकेटेड इंटेलिजेंस, उतना कॉम्प्लिकेटेड पैटर्न्स, एंड दैट्स द न्यूरल नेटवर्क का कैपेसिटी. अगर हमने उसका वाइड बनाया तो इट्स लाइक वी हैव मोर डेवलपर्स बड़ा है,
Hmm.
बट डेवलपर को मैनेज करने वाले मैनेजर एंड ये नहीं बड़ा है. सो दिस इज द वाइड न्यूरल नेटवर्क जो सिंपल लेयर्स रिलेशनशिप
हाँ, तो
सीखेगा.
जैसे अगर ज्यादा डेवलपर्स है मतलब उतना प्रॉब्लम इज लिनियर इनफ दैट इट कैन बी सॉल्व बाय मोर मैन पावर रादर
यस.
देन मोर मैनेजमेंट.
यस.
बट अगर तुम्हारे ज्यादा हायरार्कीज है देन प्रॉब्लम इज कॉम्प्लेक्स दैट यू नीड मोर stacks of managers to manage the chaos in the problem statement.
परफेक्ट. परफेक्ट. दिस इज कैपेसिटी. जितना बड़ा नेटवर्क उतनी ज्यादा कैपेसिटी. सो लेट्स डू दिस थिंग. लेट्स कॉपी दिस कोड. ओके, सो वी कॉपीड दैट कोड. सो यहाँ पे वी हैव मॉडल वाइडर एंड डीपर. एंड इन
Hmm.
लास्ट लेक्चर वी सॉ अ समरी फंक्शन. सो यहाँ पे अगर मैं से मॉडल डॉट समरी, यू शुड बी एबल टू सी मॉडल की समरी प्रिटी नाइसली. यहाँ पे नंबर ऑफ पैरामीटर्स वगैरह कुछ भी नहीं दिए बिकॉज इनपुट शेप वी हैवंट गिवन. सो यहाँ पे इफ आई जस्ट से इनपुट शेप 3 and I say it at the every place, the summary should be a lot better. Okay, so
Yes.
first layer, output shape is 16 because utne hi number of neurons hai. This is number of neurons here. This could have been called as neurons also, but अभी उन्होंने इसको यूनिट बोला है तो यूनिट बोला है, क्या है अभी क्या है. तो ऐसे then we have wider का thing. It has 32 neurons. हर एक न्यूरॉन को इनपुट शेप है 3, इसलिए there are 3 weight values for each neuron and there are 32 such neurons, इसलिए 32 into 3 is 128. दिस इज हाउ द कैलकुलेशन इज, एंड हर एक लेयर का बायस होगा. तो अगर आपको ये देखना है वाइडर डॉट लेयर, तो इसका वेट इज
जैसी दिया तूने मेरे प्यार. Every time this kind of things happen, I just sing this song.
yes. And this complicated thing, trainable dot weight. हाँ, I think PyTorch has this weight, and यहाँ पे bias तो है. Let's see why is the weight not there. Bias है. So why is weight पता नहीं क्यों नहीं है. बट या इट इज वेट एंड बायसेस, एंड ये पता नहीं इसने वो फंक्शन क्यों नहीं इंप्लीमेंट किया.
सत्यनारायण की पूजा करवाओ, तुम्हारे
Yes.
सब प्रॉब्लम निकल. Every time you start try to show me something
to
and then
simplify.
it's to simplify, and then you're like, look at this, I have simplified your problem. It's traumatizing.
Make a bigger problem, and then compared to that, the previous problem is now simplified. That was the whole point. Okay, अभी फुल स्क्रीन कैसे एग्जिट करूं? तो ग्रेडियंट डिसेंट हुआ. ये था सिंगल न्यूरॉन, और ये ओवरफिटिंग एंड अंडरफिटिंग. व्हाट इज अर्ली स्टॉपिंग?
अर्ली स्टॉपिंग इज लाइक, अगर तुम्हारा वैलिडेशन पे जो ट्रेन हो रहा है, योर लॉस फ्लैटन्स आउट, मतलब उसके बियॉन्ड और नेटवर्क सीख नहीं रहा है, तो यू कैन स्टॉप द ट्रेनिंग टू सेव योर रिसोर्सेज.
तो न्यूरल नेटवर्क क्या करता है? इट्स अ लॉस मिनिमाइजर फंक्शन. ओके,
हाँ.
इट ऑलवेज मिनिमाइजेस लॉस नो मैटर व्हाट. So just look at this blue line. So as and when you randomly pick a input data point and you reduce the loss, that's what gradient descent is. Minimize the loss, reduce the loss, reduce the loss. It will keep on going down, 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 down. But at some point it is gonna go overfit. That's when the loss, wherein validation is what it is, like a data we use to test how good the network has learned. So it, as and when the training loss is going down, validation loss will also go down, and then it will start going up. So this is a pattern for any network. If you keep it training long enough, ये pattern आएगा ही, ठीक है? And then scrolling down, if when you follow this notebook, this is how they have plotted the graph. जैसे डेटा जा रहा है, if we keep it going long enough, eventually the validation loss will start increasing. Okay, so stopping before that is early stopping. Stop before you get worse, as simple as that. So then,
the analogy
yes.
I use is when you make art, तुम ऐसे थोड़ा सा और until there comes a threshold, उससे आगे कुछ टच किया तो खराब हो जाएगा, तो तुम रुक जाओ वहां पे, and तुम नहीं रुके तो खराब हो जाएगा.
Even stand up में रहता है ना, quit while you are ahead, quit at the peak, don't keep going, नहीं तो Game of Thrones हो जाएगा ऐसे.
Yes.
Okay.
Quit while you're ahead. Yes.
So then, चलो, I'm gonna skip this dropout and batch normalization because अभी के लिए तो छोड़ दो. Let's go to the binary classification. So accuracy is, what is accuracy?
Accuracy is your correct predictions to total predictions ka ratio.
Perfect. If accuracy is 100%, means network has learned, means error is minimum. जितना error कम, उतनी accuracy ज़्यादा, and this is the relationship. And यहाँ पे we calculate it through different functions. It's all mathematical functions. It's always mathematical functions. तो ऐसे this code, simple model code, and यहाँ पे model.compile के through we specify कि error क्या है, and उसकी accuracy जो हम measure करते हैं वो क्या measure करना है. Error function is a mathematical function. It's error minimization. Whereas
And it will
accuracy,
change according to the type of problem.
yes,
So पहले वाला regression में where you're just predicting one value like share price or whatever, it just has to calculate how far away from correct prediction you are. So उसके लिए it's a different mathematical function, mean absolute error. But इसमें जो classification है, you're dealing with probability distributions कि ये भी हो सकता है या ट्रक भी हो सकता है कार भी हो सकता है. तो cross entropy is a different type of mathematical tool that calculates the gap between two probability clusters. So that is why we use this over here, and in regression it's a different loss function.
डिफरेंट प्रॉब्लम का एरर कैलकुलेशन डिफरेंट वे में होता है. एंड जो भी है यू कैन सिंपली रिमेंबर, क्लासिफिकेशन का एक टाइप का होता है, रिग्रेशन का एक
हाँ,
टाइप का होता है.
regression का
इट्स
एक
अ वेरी
type.
सिंपल मैचिंग, इट्स जस्ट अ वे ऑफ मेजरिंग एरर. ठीक है. एंड
हम्म,
मेट्रिक इज व्हाट वी अंडरस्टैंड. तो एक्यूरेसी वी अंडरस्टैंड एंड मैथ्स अंडरस्टैंड्स लॉस, एरर,
हम्म.
ऐसे. एंड यहाँ पे अर्ली स्टॉपिंग एंड ऐसे करके ये करते हैं. सो द ट्रू ट्रेनिंग ऑफ अ न्यूरल नेटवर्क हैपेंस हियर. When we say model.fit, it is trying to say randomly I'm going to pick all the data points में से एक. I'm going to do prediction, फिर I'm going to calculate error, and then I'm going to do gradient descent, and then I'm going to pick the next point, and this is going to keep going on 1000 times. Epochs means same data कितने बार repeat हो रहा है. So this is going to happen, and before the validation loss starts getting worse, early stopping will stop the model. तो ये मॉडल ट्रेनिंग इज व्हाट इज जनरली द मोस्ट एक्सपेंसिव इन टर्म्स ऑफ कंप्यूट एंड टाइम. एंड मॉडल आर्किटेक्चर ये ऐसे होता है. तो वंस यू काइंड ऑफ लाइक हैव एन आर्किटेक्चर एंड ट्रेनिंग, यू आर डन. सो एलएलएम्स भी ऐसे ही होता है, बट ऑफ कोर्स द मॉडल इज बिगर, एंड ऑफ कोर्स द ट्रेनिंग टेक्स 3 months with thousands of GPUs, but the net principle is exactly the same. So going back to the Google document, the learning goals were create a fully connected neural network, then neural network to see this solve a specific problem, training a neural network with gradient descent. हर एक स्टेप में क्या हो रहा है, कैसे हो रहा है, this thing you can see the code in hands on. And then improving performance with few things. ये skip इसीलिए किया क्योंकि this is more essential. 1 to 3. So this is our first lecture and उसके learning goals and उसकी revision done by now a good student. So next इसमें हम इसको लेके we will go to a computer vision problem जहाँ पे truly एक image classification होगा. ये थोड़ा सा चिंदी डेटा ही था. एक कितने पता नहीं 600 लाइंस थे, वाइन डेटा या कुछ तो था. बट इमेज डेटा में जब हम चालू करेंगे, यू विल रियलाइज 18 पिक्सल के भी इमेज को क्लासिफाई करने में वाट लगती है. 18 पिक्सल, हम 10
Because
10 मेगापिक्सल पे है
machine के
अभी.
लिए कुछ meaning नहीं है ना image का, they are all numbers and probabilities for the machine. So it's like that's how I have understood so far. तो उसके वजह से tough है.
I'll add a correction here. मशीन के लिए मीनिंग नहीं है, और मीनिंग देने के लिए हमने नेटवर्क दिया है. मेरा हिसाब से क्या है ना, बिकॉज हमें इमीडिएटली दिखता है एंड वी कैन इमीडिएटली प्रोसेस एनीथिंग, वी फील लाइक ऑब्जेक्ट आइडेंटिफिकेशन इज अ सिंपल प्रॉब्लम.
हाँ, it's
तो
not.
हमारे इट्स नॉट एग्जैक्टली. 18 पिक्सल में भी जब पीसी की वाट लग रही है, उसका बेस्ट एग्जांपल इज ना, इज दिस द फर्स्ट टाइम कन्वोल्यूशनल न्यूरल नेटवर्क का डेमो हो रहा है. सो दिस गाय यान लकुन, नाउ फेसबुक का रिसर्च साइंटिस्ट, वन ऑफ द बिग नेम्स, और वो कितना खुश हो रहा है ऑफ टू व्हाट प्रॉब्लम. ये ऐसे एंटर एंड टिंग टिंग टिंग. सो इमेज क्लासिफिकेशन ऑन 18 पिक्सल, 28 पिक्सल, वो भी कॉम्प्लेक्स है. सो व्हेन वी नो कि हम 10 मेगापिक्सल पे कर रहे हैं, तो देन यू लाइक ओ फक, ऐसे ऐसे होता है.
Even
तो
brain में सबसे बड़ा
yeah,
resource heavy is vision,
विजुअल कॉर्टेक्स.
visual
न्यूरोसाइंस बैकग्राउंड
cortex.
गाइस. यस, देखते हैं यहाँ पे विजुअल कॉर्टेक्स दिखाता हूँ. विजुअल कॉर्टेक्स V1 V2 V3 and V4. So this is how the visual cortex is. Whenever any image comes, it goes through things like this. And these we can say are different layers. जितने डीपर जाएगा उतना ज्यादा कॉम्प्लिकेटेड प्रोसेसिंग होती है. ब्रेन ऑल्सो वर्क्स द सिमिलर वे. हमने रादर ब्रेन से ही इंस्पायर किया है. ब्रेन डजंट वर्क सिमिलरली, रादर नेटवर्क इज बीन कॉपीड टू वर्क लाइक ब्रेन. तो ऐसे. सो दिस इज गुड लेक्चर, गुड दिस
Yes,
थिंग.
good.
नेक्स्ट इज से विल डू समथिंग नेक्स्ट पार्ट ऑफ द सीरीज. ओके,
Yes. Thank you.
चल सी या, वेलकम.